N.S. Pradeep, who introduced the speaker. I also extend my gratitude to the audience for this attentive listening. Thank you. Thank you very much.
Thank you, sir. We are now starting with the next memorial lecture, M.S. Swaminathan Memorial Lecture. May I request the esteemed dignitaries to kindly occupy your seats on the dais. To welcome and introduce the speaker, we have Dr. Manoj P. Samuel, Executive Director, KCST CWRDM, Kozhikode. Our expert speaker for today is Dr. C. Anantha Ramakrishnan, Director, CSIR NES, Thiruvananthapuram. And I also request Dr. K.B. Ramesh Kumar, Principal Scientist, JNT BGRI, to kindly occupy your seat on the dais. Sir, please. To welcome the gathering and to introduce the speaker, I request Dr. Manoj P. Samuel, Executive Director, KCST CWRDM, to please proceed.
Respected Speaker, Dr. Anantha Ramakrishnan, Director, NIST Trivandrum, other dignitaries on the dais, my dear delegates and friends. I'm very happy and privileged to invite all of you for the second Professor M.S. Swaminathan Memorial Lecture. As all of us know, Dr. M.S. Swaminathan doesn't require any introduction, but even though a few things about him, he is the father of Green Revolution in India, and he is the only one person who was awarded with all three civilian awards: Padma Shri in 1967, Padma Bhushan in 1972, Padma Vibhushan in 1989, and Bharat Ratna in 2024. It was exactly on the same day last year during the 36th Science Congress when Professor Soumya Swaminathan, she was on the dais for the memorial lecture. That time Bharat Ratna was announced in honor of Professor Swaminathan. And he received 73 honorary doctorates from different universities around the world. And we have a very distinguished personality for having the M.S. Swaminathan Memorial Lecture today. Is Dr. C. Anantha Ramakrishnan, Director, CSIR, National Institute of Interdisciplinary Science and Technology, Thiruvananthapuram. Dr. Anantha Ramakrishnan is an Indian scientist and academician having expertise in chemical engineering and food processing. Earlier, he served as the Director of National Institute of Food Technology, Entrepreneurship and Management, Tanjavur, NIFTM Tanjavur. And he obtained his BTech from Anna University in Chemical Engineering, MTech also from the same university. After that, he moved to UK for his PhD, and he got the prestigious Commonwealth Scholarship for his PhD studies. And his research activities are focused on scientific eminence, aiming on societal benefits and industrial relevance. His key area of research is on development of Asia's first engineered human stomach and small intestinal model system, mimicking the complex biomechanical and chemical function of human digestive system. Further, he developed India's first indigenous food 3D printer and India's first scientific publication on 3D food printing. Recently, his publication reported that the printability of egg fraction and food fibers based on the personalized nutritional requirements. And he is also an expert in spray freeze drying and electro-spray freeze drying of food ingredients. And he developed conditions for micro and nano encapsulation of nutraceutical ingredients for potential health benefits. And he also launched Mission Onion Program and Mission Coconut Program. And recently, he got the most prestigious award the government of India bestowed on any scientist, that is the former Shanti Swarup Bhatnagar Award. Now it is called Vigyan Shri Award, Rashtriya Vigyan Shri Award. And our Honorable President of India bestowed that award, conferred that award on him a few months back. He also got the Tata Foundation Award and many international awards. He's a fellow of many scientific societies, including National Academy of Sciences, National Academy of Agricultural Sciences, National Academy of Chemical Sciences, and many more. So that the most eligible person only today today is with us for having the M.S. Swaminathan Memorial Lecture. Sir, with a great happiness and privilege, I invite you for this lecture. Thank you.
Thank you so much for wonderful introduction. First of all, I like to thank organizers, especially KP Sudhi sir, invited me to come today. I was wondering, that too, sir has called me for the memorial lecture of Professor M.S. Swaminathan. Is it I am relevant to that or not? Big question mark with me. So in that background, I prepared my presentation today. It is a future of food. Without food, nothing is there. We all live for that food. And the changing climate, just now you would have witnessed how fast our climate is changing. Is it is going to impact on the food or it is impact on our health? That's what all my talk all about it. Bharat Ratna, all the list you can see that whatever the award in the world, everything he got, except Nobel Prize. Maybe the food prize sir has got, professor has got. But look at 1999, that millennium. Times has brought up who are the people are influenced in that 100 years. Two people from India. One is that Mahatma Gandhi. Second person, time is listed, Professor M.S. Swaminathan. Nobody else from the India, only two personalities listed, influenced the whole world to make mankind. Would have celebrated a little bit better, but still, today we are getting 382 million tons of the food grain, record production of the food grain. During the COVID time, we have more than 100 million tons of the buffer grain. That's what we could face any problem during the 1.5 years of the COVID time. Now we are world number 1 in milk, vegetables, fruits and vegetables, even pulses, oil seeds. Everything is happening from the one person. Along with that time, C. Subramaniam, who was that minister of our center, they put up the program for the country. That's what today we are self-sufficient. My interaction is very brief. When I became a director of NIFTAM Tanjavur at the age of 42, I don't know how to take it forward that time. Just after taking over, first person I met is Professor M.S. Swaminathan. I asked, sir, what I have to do that institute? He said only one thing, concentrate on the society. Agriculture and food directly connected to the society. Whatever our action, every day, every minute, think about the people who are not able to still access to the 3 meal of the food in the country. Is it anything you can do? That's what you need to look into that. That's the advice. Every year, August 7th, I will be there in the center, MSU Saraf Center. I used to meet him, get a blessing, but I will update what I have done that 1 year. That I followed till 1 year back. It is the really big journey for me that time. Maybe Sudhir sir has when called me to do this one. Today morning I sent a message to Soumya ma'am. Ma'am, today I am giving CSN, really the apt person, give the talk. I'll go with that, what I committed to Professor M.S. Swaminathan, sir, and what I have done as a director of NIFTAM Tanjavur. Then I switch over to the topic what I wanted to give. I took over as the director of April, and the June month, newspaper has flashed some news in the Perambulur district where onion farmers are struggled to sell the onion. Even some farmers are attempt. I was thinking what we are doing at the institute just 50 kilometers away from the farmers are struggling. Then I took the bus. I called all my scientists and students to that bus. They thought, well, this fellow is young fellow become a director. He is taking us for excursion. I took them bus to the Setikulam village where the hub of onion growing in Tamil Nadu. That is the Perambulur district. I told them, go to the field, talk to the farmers, find out what is the problem they are facing. Today evening, 3 o'clock, we will meet again back here. If you are not giving the solution, we are not going back to the Tanjavur. That's what I told them. We met most of the farmers, everyone. We came to know the salad onion, the small onion. Till that moment, we don't have the machine to cut the root and stem. Women are sitting in the hot sun of around 38, 39 degree son, they are cutting in the hand. Second one is the value addition of the small onion. Normally, per acre, whatever they put investment, it goes for the 30 to 40,000 rupees. Most of the time, they take the loan and they cultivate 3 months crop. If they sell it above 10 to 15 rupees, they will get that 3 months 10,000 rupees profit. If rate goes less than 10 rupees, even they can't able to pay what the loan they taken. That is the situation of the farmers. So we thought of to increase the value addition. One is that peeling the onion is the one. Sambar onion needed for the industries, especially hotel industry. Can we make the peeling the onion machine? That's what decided that time. We returned back the institute. I stopped all the research in the institute. Morning to evening, only one objective, to develop the machine for peeling the onion, value-added product, all the things. Believe it or not, 28 days, we could able to make that machine. That's what this machine is. We made it. If we add a small onion, it goes to the conveyor belt, and we use that air to remove the skin. What we have struggled to remove the skin, we able to do that. Then we made the onion flaky paste and 5 product, and we created the onion incubation center at Setikulam village. There, you can see that women are bringing the onion to there, and every day morning to evening, they bring the material, they process it, they're selling to the market. We made the 1,000 farmers producers company. We linkage, backward linkages, forward linkages, marketing, everything we have done within 100 days, including the building. Everything has been done with the support of Tamil Nadu government and the central government. The work is not stopped at that point of time. Our Puspa Subramaniam secretary, madam, visited there. She astonished, how come this is happening, this many work in the village? Why not you can't convert the throughout the country? She told me to that, is it possible to make it the same model? Whole country can get benefited. Luckily, after the COVID, 20,000 crore was allotted to Ministry of Food Processing. I told, madam, can I write a scheme for that? She said, why not? That time I was involved in the one country, one product in the FAO. I know that concept of how Japan is implemented, one village, one country, that every village, how they converted. The same model I adopted. We created one district, one product. Today you would have seen that name everywhere, and the PMFME scheme. Within 24 hours, we returned the scheme. We submitted the central government, and today, because of that scheme, 1,05,000 entrepreneurs got benefited. Not only that, we created 70 incubation center. One is that the same Kerala Agriculture Institute, KP Sudhir is here. We approved that incubation center. Even 5,000 people have got benefited out of that. What I tried to say that one institute, one intervention of the science, how it is that transforming the whole landscape of the science. That's what we need to think. I wanted to again to say thanks to the professor. I'm a pure scientist till that moment. He said, your science has to reach the society. Only that connecting dot, we need to think about it. These are some other examples. I'm not going for detail, but 1 or 2 points that Manjula came for the institute for the job. I told her to go for the training. She had done for the PMKY's training. 2 units she opened. Now she's exporting more than 5 countries. Then Vadamalai, he also came. 2nd unit I inaugurated recently. Even he showcased his product to Honorable Prime Minister. They all come to that institute with the 5,000, 10,000 rupees. They become entrepreneurs. The success story, not 1 or 2. Right now, more than 123 success stories. These people are they're first-time entrepreneurs. They come to the Niftam Tanjavur, they become entrepreneurs. It is a possible. How we are going to handhold our people, or the entrepreneurs, or the farmers, we can convert it. With that note, I have not stopped that point. During the COVID time, I tried to reach out the kids. They are not going to school, but we need to make them to connect with the teaching. We try to do with the Niftam and other. Then I felt the food is the main problem. And if you look at most of the midday meal program, yes, we have done very well in the midday meal program. The concept of midday meal program giving the energy or calories. The cost also 7 rupees to 10 rupees only government is allowing. How much nutrient you can give? Still, Kerala is very good, but other states, even Tamil Nadu recently, some of the states suffers the malnourishment. Can we address that one? Then I thought of more than a midday meal, breakfast meal is important for the state like a Tamil Nadu or other states. Then I made the program and the model system also. can we supplement iron and protein, because protein deficiency also increasing. Then I proposed that proposal to the Tamil Nadu government. Initially it was some struggle, later it was implemented, I was part of that. Today whole Tamil Nadu getting the breakfast meal. That is the scheme, it works well. We have the back-end data, they are economically improved, and the women who cooks for the meal for the kids, they are also free from morning, and the kids are studying well, because they take the dinner 6 to 7 o'clock, then come for the school, 12 o'clock only they are getting the meal. So that gap we tried to fill. Today I'm very happy, whole Tamil Nadu, the scheme is implemented, and also I created, instrumental to create a Tamil Nadu Food Processing Corporation to increase the income of farmers, increase the food processing sector, because food processing sector, one can yield more employment. This I, not promoting myself, just I wanted to say the journey what I started from MS Swaminathan to this, apart from my scientific journey. Now I'll switch over to the science. Future of the foods, climate change. How it two are interact. First I will start with the future of foods. If you look at the Indian food industry, one of the fastest growing industry, it is almost 10% per annum last 10 years. No other industry is growing more than 10%. Country's growth rate 5 to 7%, food industry is growing more than 10%. We predicted 535 billion in 2022. We beaten 866 billion size of the market already created, is predicted 1,200 billion market. Think about the size of the market, one sector is growing. And the export market continuously in the stream. The last column, if you look at ready-to-eat, ready-to-cook product market, reached 900 million. That means 16% market share and 16% growth rate. That thanks to the COVID, because we tried to eat all, ready-to-eat all noodles, pasta, everything we are eating. But one beauty of this sector is 98% of the sector is MSME. MSME means it directly connected to the employment. That's what we need to support this segment, how fast we are going. 100 years back, we used to take a food for the energy. 50 years back, we started thinking about nutrition. Now we are taking food for soul. That means we have wanted to enjoy the food. If you go to the mall, you have the movie theater, 5 movie theater, 20 food restaurants. And every weekend we wanted to go to the restaurant, take the foods. That's what people change the mind, and they want a customized food, nutrition, different product, and the brand. Coffee, you will get a 10 rupees coffee in one's shop. You go to the another mall, you get another 100 rupees. If you go to the branded Starbucks and all, you get 400. The same coffee, but the brand decides the cost of the product. So all these things happening around the food sector, how are you going to do that? The future food is the engineered food, nutraceuticals, and the market-driven food structure and industry. Introduction, Sir has mentioned about 3D food printing. Yes, this is what I mentioned. I visited a lot of schools, how to supplement this nutrient food to the kids. That's what initial I thought of doing it. Then I taken some statistics. Kids told they like chocolate. Then we thought of, can we make the chocolate with the nutrient chocolate? Okay, we can make the chocolate, how to make it a bulk production at the school level. Then I come across, can we do with the 3D printing? That time it cost was 25 lakhs, the printer cost. So I thought of, we can't afford 25 lakhs, we can't put it in the government schools, especially corporation schools. Then I thought of to start an indigenous printer. This is the first printer what we developed, the cost of 80,000 rupees. It can print even snacks, material, and we brought science as well. We brought first paper on the egg. We come across the millet. Can we go with the printer can produce the fiber-rich product like a 17% of the fiber, 10% of the protein. That means GI will be low. Then whichever the shape you want a butterfly shape, you can print. You want your enemy's face, you can print. That's what the 3D printer offered to do that. We have done a lot of things. We moved on to the 3D printer to 4D printer. What is that 4D printer? It is a size and shape or color changes. For example, you can print the sheet type of pasta, you put it in the hot water, it is twisted. After putting the hot water, it twisted. Otherwise, the color changes. When you put the product into the liquid, it color changes, flavor changes. The 4D printing, 3D printing, all we developed in Niftam. I'm not going for the detail on the research. I wanted to give the glimpse, yes, science, how we can use it for the future of the food. If you look at the nutraceutical and the functional foods, now our average age is 72 years. When we got independence, our average age was 28 years. 10 years back, 2012, our average age was 62. Within these 13 years, we increased almost 10 years of our lifespan, thanks to all the health sector and the government initiation. But still, look at, we are facing the huge problem for anemia and stunting. Think all the countries except Africa has the overweight, anemia and stunting. And Western countries, mostly in the overweight, are the stunting. But here is the unique problem of all are associated with the different sector. India ranks 105th out of 127 countries in the Global Health Index. Even some of our neighboring countries are better than us. That has the different matrix. Government of India has not fully accepted that data, but overall, if you look at, yes, we are not doing well. Even anemia, if you look at India, 35% of the men are anemic, 53% of the women are anemic, 65% of the children are anemic. Kerala is doing well, only 33%, but all other states suffering in anemia. But diabetes, Tamil Nadu and Kerala suffers most. We are leading the diabetic in the country, and India is second largest diabetic population in the world. If you look at morning, we take a puttu, afternoon rice, again night, again going for rice and all. All in the different form. Tamil Nadu, if you take idli dosa, rice form only we are taking. We are not able to take adequate amount of the protein. Rice comes almost 6 to 7% protein in fermented. Then again, GI will increase. If you eat this rice, spiking of the glycemic index very high. How to solve this one? One is the anemic, another one is the diabetic. If you are not solving this one, we are the youngest nation. When we wanted to celebrate Viksit Bharat, our 100th year of independence, that time we are going to be oldest nation. How are you going to handle this many populations? So we thought of working on that. Initially, I start working on the iron nanoparticles to deliver us because iron absorbs only 10%. Whatever you supplement, whichever form, our body won't take it more than that. One way is we make it a nano-size particle of iron, it absorbs 3%, 30% higher. That means 30% it will absorb in body. Then we thought of to supplement through the different mode. One is that rice. Rice fortification, Government of India introduced, even all the states including Kerala is implementing, but it is not adequate to address the not only malnourishment. Right now we are putting only iron, folic acid, vitamin B12. I am the part of that committee to standardize this whole process. Later I realized it's not adequate. We need other nutrient, other macronutrient needed, including the protein. But GI of this rice goes to almost 70, 65 to 70. Again, diabetic population takes this one, spiking will be happens. So how are you going to address? That's what we are working on, that making the low GI rice at CSIR NIST. And we are using the extrusion method, 3D printing method to do that. Spray drying is the unique method to convert all the powders. For example, coffee, the milk powder, single unit operation it converts it. Can we have an alternative to spray drying? One is the freeze drying, but freeze drying takes longer drying time because layer by layer it dries. We wanted to use the combination of spray drying and freeze drying called a spray freeze drying. This is the rig has been constructed at Loughborough, UK, but we modified at NIFTM Tanjavur as well as NIST Trivandrum. Can produce the porous size structure. It is like a spherical particle, but sponge-like structure. This can be deliverable for the vanillin or the whey protein, DHA, probiotic. That is a very high heat sensitive product can be deliverable using the spray freeze drying technique. That's what we have done. Market driven, one product is continuously going on the market driven. That is the artificial meat. I don't know if it's a hype or not, but some of the segment throughout the globe, they are telling veganize the food, vegan foods, all these things. But the mankind, we enjoy the saltiness, taste comes from the meat. Can we get a meat like a structure, taste like a meat? That's what this market is going up. We are also developed, this is not from the meat, you can see the structure itself. This has been created from the millet. Texturize the protein. With the particular temperature, you texturize the protein. That means you denature the protein, break down the OH bond, you join with, aggregation happen, then you can have that type of fibrous material like a meat, then you can get it. But big challenge is, meat protein is the highest digestible protein. For example, egg protein is a 1. But the grains or the millets and all, it comes 0.6. That absorption of this protein is the big challenge. That's what we try to address in the texturize the protein and the solubility of the proteins. Then we can supply almost 20% of the protein per gram of that. Another idea is take the stem cells from the animal, grow the meat at lab. This is the what right now a lot of people are working. So you get as good as the meat. It's almost meat, but you are growing in the lab. But the market also going very, very rapid phase, and you can supplement with the fat, and that you can enjoy with such type of product. Protein. Protein deficiencies right now, it's a very, very steep level increasing. We need to find other alternative soluble protein. One is that insect protein. A lot of Western country already using that, how to utilize the insect protein. For example, if you make it a 10 kg of the feed, insect will give 9 kg of the meat, out of that 72% of the protein. But the same 10 kg of the feed, if you give to the beef, it gives 1 kg of the meat, 52% of the protein, then 48% of the fat. That's what, if you look at the protein as such, the better alternative is that insect protein. That's what a lot of people are going into that. Even China, you know that they are doing a lot of work on that. We need to also think about how to cultivate these insects, then get the protein out of that. Salt, if you see that how much amount of the salt, we are taking more than 17 grams of salt per day. We should not take that much. But without salt, we can't eat any food. So one way is how to alter this salt. So we are doing it with the size. If you reduce the size, like for example, nano size salt, so if you instead of taking normal 100%, only 30% of the salt is enough, because surface area increasing, it goes to the taste buds, sensitize, more salt is coming. Even you can add magnesium and other ions to get very good saltiness. That's what CSI and NIST is working. Now we replace the sodium with the different ions. Almost only 10% sodium using, remaining all 90% different ions. We have made the designer salt. Some of the companies already interested to take our designer salt. Structure, food structure is another one. Okay, we made all the product. You need to test somewhere else. Where to test? I said I made the iron nanoparticle. We could not able to test this iron nanoparticle. Can we do that artificial way of testing? That means we need an artificial system. For example, 115 million animals used every year, but sometime it is okay. For example, HIV, it passed in human but failed totally in the animal system. So that means we need a different system. These are the system right now is available, artificial human digestive system. If you look at here, this is the stomach, this is the intestine. And this is the conical type. They create the pressure like what stomach is created. So we try to do the same thing. Initially, I went to go with the pig model. Pig is coming very close to the human GI system. The same stomach, our capacity is almost 1 liter capacity. Pig capacity goes almost 2 liters. So we took the pig stomach, we tried to recreate that. Almost we wasted 1.5 years. Then we realized we need to go different methods. So we did the MRI scanning of stomach. Per minute, 120 image, that means per second, 2 images. We converted the 3D image, we 3D printed the stomach. Then we created actually what is happening in our stomach. This is the contraction takes place, 2 mm per second, the contraction goes. This is the top is that where air gap is pushes the meal and the pyrolic is opens. When pyrolic is open, that's still a lot of theories are around, but we are not able to get concluding that. That's what challenge was there. So we use the computation modeling method, how to mimic the stomach as such. For example, you take the meal, if your pyrolic releases the very slow release, the glucose goes to the intestine, you can manipulate. That is the idea. So emptying rate can be calculated. That's what we have done, different emptying rate. This is the study, if you look at, we have done MRI scanning using the opal as well as upma. We feed both the meal, the emptying, how is emptying is happening, and we draw the blood. You can see that we calculated area where is emptying is happening. You can see that 0 minute, this is the air gap, this is the full meal. When 30 minutes, air gap is increasing and reduces the meal. When it's 120 minutes, almost total meal is empty. So that area we calculated, that emptying rate, we have put it here. It's almost matched with the two set of the ages, 40 to 50 years age, 20 to 30 years of age, our system works almost closely with the human. So that's what the system is work very well for the emptying and the contraction. Then we went on how the absorption takes place in the intestine, both jejunum and ileum and duodenum. We use the different mathematical model to predict how the glucose predictions. Normally, if you look at first initial result, we got just opposite to that. Then we will add the insulin factors, then this portion has come very well, but still this portion is not at all good. That means body always has the glucose, because you can't, even fasting time glucose is there. That we are not able to do that. Later we added that glucose factor, we could able to predict exactly the same. That's what we have done the real system. Right now this system is in CSIR NIST. It can be predict any amount. We no need to change the fat soluble or the water soluble. All the matrix can predict. Then you can use it. Anyone interested to use this system, please visit to CSIR NIST. It's available. We can use the modeling system, how you can model your process model. For example, the beer bottle, you need to make sure that center of the temperature of the beer bottle should be unique, the 64.5 degree. Then only you can kill the Saccharomyces cerevisiae. How to predict? Each bottle you can't put the probes. So what we did, we predicted the whole model with the computation fluid dynamics model. You can see that experimental, our CFD model works really well. Not only that, we could able to predict Saccharomyces cerevisiae inactivation kinetics. So just I want to give the glimpse, yes, modeling also helps. And the blockchain technology we used in the CSIR NIST this one to use the mapping the millet, how the farmers grows, what are the value addition and where it ends, the total thing from your mobile itself. Just you buy any millet product in the market, the QR code, you know that who are the farmer produced for you, where it is processed, where it ends. Everything can be mapped and can be known from your label itself. That's the idea. We developed this blockchain technology. So these are the new area, what we are thinking, 3D printing, food structuring, and new age of scanning or the modeling or the blockchain. But the climate change, often we used to say climate has changed. No, climate has not changed. We forced climate to change. Look at 1970 to 79 and 2010 to 19, that gap. 300 floods, it's become 1,200. Fire, 30,127. Storm is almost 4 times higher. If you look at the temperature, surface temperature of the earth, right now it is recorded 1.37 degree temperature. We can't afford to increase more than 1.5 degree. Ideally, we have to control. If it goes beyond 2 degree, Antarctica melts. One of the speaker earlier has shown very well. But look at that shift takes place 1990, where industrial revolution started. Immediately the surface temperature is increased. It's not only the other sector, what we think as a power or motor vehicle, our agriculture sector also increasing. If you look at 1990 to 2023, 20% increase in the GHG emission is more. And then if you look at 23 to 23, we are not done much there, but all other sectors are increasing. But if you look at the overall agriculture sector also, it is increases the greenhouse gases. That's what we need to look how best we are going to control. If you look at the whole value chain of the food processing, is the raw material goes, immediately farmers, producers, the primary processing, then value addition, then packaging, marketing, export. Each and every point of this whole value chain, CO2 is released. Either production side, yes, for example, meat or the fish, aquaculture, CO2 released, then goes to the primary processing, energy input, value addition, everywhere CO2 is released. Believe it or not, 26% of the greenhouse gas emission comes from our sector, is the agriculture sector. That is the biggest junk we need to address. 70% of the area we are using, and almost 50% of the potable water used for the agriculture purpose. If you split this greenhouse gas emission, processing contributing 3.5%, production contributing 40%, packaging contribute 4.6%. That's what we need to address. Beef, it is again contributing CO2, and beer and cheese. If you convert the calories into the total what is happening, for example, chicken, you give the feed of 9 calories of the feed to chicken, you get 1 calorie amount of the meat getting. The conversion rate is only 13%. The feed itself, when you are cultivating all the grass and everything, it quite lot input is going. Second is that if you come across with the beef, 40 calories input, you get only 1 calories output, the conversion rate is 3%. That's what we need an alternative to this, either cultivated meat or plant-based meat is the best alternative to go for that. If you look at that carbonated beverages, whatever it's available in the market, PET bottle, that contribute quite a lot of greenhouse gas emission, especially CO2. If you look at packaging, PET bottle is produces 58 gram per CO2 equivalent to the per liter of what carbonated juices produce. That's what we need to reduce it. So we need to look what is that alternative for the packaging, sustainable packaging. 2010 we used 4.0 kg per person used the packaging material. Right now we are using 8.6 kg. All this packaging material goes to the sea. Every minute 15,000 multi-layer packaged are purchased and dumped on this earth. If you think about a chocolate, you are enjoying the 5 minutes of the chocolate sweet, but the wrapper what used in the chocolate is aluminum along with the PET. It takes 10 years to degrade. That is the biggest time it goes on that. 5 minutes enjoyment, wrapper takes degrade 10 years. But still we are using most of the packaging material, flexible packaging or rigid metal and all. Paper is not an alternative. People are used to say paper can be used everywhere, the paper used. Paper, you are deforesting and 15% less absorption. Converting the paper wood into the paper, it takes huge energy than what you are thinking in the plastic itself. What we are estimating is 1.3 gigaton of CO2 emission in 2030, that is equivalent to the 300-500 megawatt coal plant. That is the biggest amount of the CO2 is going to come. If you take it the plastic as the whole life cycle, 380 million tons of the plastic is produced, 40% only recycled. That means 190 is totally wasted. That much amount is wasted. 1 million animals are died. They think plastic as the food. That's what it dying. And we are taking in the lifetime 18 kg of the plastics. Right now in the sea, 1:3. 1 ton of the plastic and 3 ton of the sea fish are there. 2050 it is going to be equivalent to that 4 ton of plastics and 4 ton of the fish. This plastic is going to come to us. You can see that all our seashores and everywhere it is there. Right now we are taking 5 gram of plastics per week, equivalent to the 1 credit card. Earlier we thought of this microplastic is not going or crossing the blood-brain barrier. Right now, lot of studies established it crossing the blood-brain barrier. Because of cell membrane is 75 nanometers, less than 75 nanometers particles will cross the blood-brain barrier, even it goes to the mother's milk. That's the what data says. That means you see that whatever we are throwing the chocolate papers or the plastics, it's coming back to our body. That indirectly impacted on our health, including the cancers and all. Even 500 microplastics are present in the drinking water of Mumbai, and 150 microplastics in Thoothukudi as recently found. And NIST has taken all the food, whatever available in the Trivandrum we have taken. We have started already collecting the data of how much microparticles are present. Is surprised to know that milk, salt, sugar, coffee, everywhere microplastics are there in the market of Trivandrum. We are not able to reveal the data, but very soon we have come up with the full data how much this migration takes place from these plastics to the food chain. Not only that, if you see the value what we are losing, if you consider only 14% we are recycling, means almost 80 to 120 billion amount of the worth, we are not able to recycle it. That's a waste. And FICCI in India is a very clearly demonstrated 133 billion reported worth of material we are going to lose. But CBCB data, we don't have much data. 2015, 15 lakh tons per annum. Now almost 41 lakh tons per annum. That's what predicted. But FICCI has done a little bit higher than that predictions. That's what I said. Paper is not an alternative at all. 15 billion trees are cut down globally. That means already 15% CO2 emission is reduction. we need a 4 times higher energy needed, 70% more pollution, because you need a bleaching and water requirements is very, very high in the paper. We are advocating the paper is an ideal solution. No, we are putting a lot of stress on the both energy input. Then we are going for the multi-layer packaging, Tetra Pak and all it comes. It is a very, very difficult to recycle because it has the aluminum foils inside and the layers increases, very difficult to recycle. Then what is the alternative in front of us? Can we go for the glass? No. Glass also produces higher amount of the carbon dioxide. If you go for the recycle, it produces higher than the what it produces the carbon dioxide. And the handling and all the things is a problem in the glass. Then what material is there in front of us for alternative is aluminum. Is it aluminum is the right alternative to go? Per ton of the aluminum produces almost 4 times higher than the PET bottle what produces CO2. That's what the statistics. Even aluminum itself is not an ideal solution. Paper, glass, aluminum, then where we have to go? We need to find an alternative for sustainable packaging. Biodegradable packaging. That market is continuously increasing, but we don't have the technology. Right now, glass bottle, PET bottle, biodegradable PET bottle is not available in the market. We need to develop that one with the strength and the barrier property. We need to reduce the layers. We need a different materials need to be reduced the layers and the strength and printability. For example, papers, we need a recircularity we need to increase, and we need a coatings like a bioresin, something like that. Coatings are needed to increase the paper usage, recycled usage. Plastics, we need to find a solution to segregate biopolymers and the normal polymers. Then only we can increase the biopolymer utilization and biodegradability in the existing chemical method or any other method. We need to find a solution for that. That coating and adhesives, metals already I mentioned. And India, we need to establish testing and monitoring system. Otherwise, it's very, very difficult. Biodegradability testing method need to be established. And CSA and NIST this year itself, we are going to put an integrated testing method for biodegradability testing center will be going to come there. We are working with all the 37 lab to bring alternative to multi-layer packaging. This year itself, we are going to introduce glass bottle. Already technologies are matured, and CSA and NIST is going to come up with the biodegradable, 100% biodegradable PET bottle that can be used for milk or any other containers, and also package different source of the packaging material. We are finding out source only, not only 2-3 source, we need other source and then indicators. For example, fish and meat, when you use the cold chain, we need indicators. When the spoilage happens, can we go for the smart packaging? CSA and NIST developing the molecule to indicate the spoilage in the outside and the biodegradable testing center. All these institutions and CSA and NIST is leading to complete this mission within a 2 years' time to bring this solution to the industry, especially in India. 40% of the material used in the packaging industries are food packaging. So we wanted to reduce that one. We wanted to move on to the sustainable packaging. As I said earlier, when we are targeting 2070 for the net zero, without addressing to the packaging, it is not going to achieve. The future depends on what we do present, what Mahatma said. If you dump more and more all these things on the earth, someone will say the humans are lived in this earth. So we have to be a responsible citizens. We need to be responsibly treated this mother earth. I conclude my talk with what the Professor Swaminathan mentioned about that. If agriculture fails, everything else fails. So we never ever allow this sector, this industry, our farmers fails in to do their job. That's what we need to think, all our policy, all our thought process, everything to connect it to the agriculture, then we can succeed in everything. Once again, thank you so much for all the support, my student, my guide, everybody. That's what I could get this award with the Honorable President. Once again, thank you so much for inviting me to share my thought. Thank you, sir.
Thank you, sir, for that insightful speech. Do we have any questions from the audience?
Hi sir, I am Sumi. Thank you for sharing information regarding the food production technologies and all. Sir, my question is related to some personal, when I was searching about something related to weight loss or something, I heard that there are some supplements or nutritional things available in the market. So my question is that from your experience and knowledge, do you feel that taking these supplements or nutrition is helpful for weight loss and all? And is it good to take these?
Again, you said the personal, but still I can say the scientifically. One molecule, what I understand, hydrox is HCA, citric acid. Okay, that was initially, it was invented in India. Lewis, he has done that work at CFTRA Mysore. That is widely accepted weight loss molecule. Till now, people are using. But that will stop the conversion of the fat storing in US. Extra fat is converted into the energy. That's what HCA does it. But one model in US, she said, she used to take a lot of that HCA. She told, I'm taking more HCA, that's what my psychologically I affected. But others are not said. So still that questions are, I don't know what is that, but still HCA does the job. That means supplements, some extent works. But where is, we are missing the bus is, we are reducing the intake of the food, right? Most of the people suggested you reduce the intake of the food. But are we have the balanced diet? At least 0.7 into that, whatever the weight, you have to take the minimum amount of the protein. So you have to supplement that protein, and we have to supplement the fat. All that balanced diet has to go body. Otherwise, body will struggle to meet up that. So we need to, one side diet, we have to keep eye on the nutrition, what you are giving it. Then along with that, the supplements, if you take, it will works well. So we need a balance, then exercise and all other things. But my point, scientifically, yes, it's possible because HCA does it. I know that we have also worked on that. But other molecules, so many other molecules, they claimed it, but may works, but based on the animal studies and the scientific evidence. But same time, you have to think about your normal food intake, what you are taking.
Namaste, sir. Sir, I had the good fortune of visiting NIFTEM Tanjavur for a workshop, and my whole perspective about food processing and innovations in food technology changed. Just out of curiosity, sir, because so much of 3D and 4D food printing technology was being shown, I wanted to ask whether any of these are also being used for foods to be used in space.
Yeah, that's a very good question, ma'am. NASA has developed the printer because if you carry the food to the space, you need a wrapper. So you have to cook it again. That weight of the wrapper, it added on to that. Second, not only that, when you open up, that is the another wastage you are keeping in the space itself. And the small particle also hits because aluminum wrapper normally used. So avoiding this wrapper, freshly can you prepare? Because if you go that, every day you eat same food, no, you won't enjoy, right? That's what, when you are in the space, you needed every day different foods. So 3D printer will help to do that. So NASA developed the 3D printer. Where is the problem is, this 3D printer goes with the needle, it sprints like this. So this comes, one is the pressure, second one is the gravity. First layer forms, second layer stays there. Second layer stays because of the gravity. Then the binding between the one layer. So zero gravity, how to bind this one? That is the first challenge. Second one is that the nutrient, what you are pumping it. Normally, energy level in the space, astronauts needs more than 2,800 calories per, because whole day we need 2,200 calories. There you need extra calories, and most of the material has to absorb in body. That's the target. When you wanted to balance that on, 3D printer will help to do that. They have done, and I am also working with that some of the companies, and we are also wanted to develop the similar kind of things. But the lab to develop that one, zero gravity atmosphere lab, and that size, we need to put a 3D printer to do that. Now IIT Chennai has that one place, and another two place they have that, but maybe we can also develop such one, then that will helpful for the space station or the aircrafts, it can be used.
Thank you, sir.
But they are not revealed the technology. Still we are not knowing how they have done, NASA has done, but only they have shown the printer.
Thank you, sir. Maybe we'll see it in Gaganyaan, when our astronauts
We
go
have
to
started,
space.
but we are very difficult to do that. But if you are able to do that, you would have seen recently also now 3D print has come up with whichever the way you want, you can print it out. Even idli can be printed with the chutney inside, like that. Lot of things now people are developing. Even fish can be done. Recently, Israel has done fish. So printer has moved on to the very different stages. So this is another stage, space printer.
Thank you, sir.
Sir, I have one doubt. Is there any possibilities to replace plastics with biopolymers like cellulose and chitin-made biodegradable biopolymers in food industries especially?
Yeah, that's what you know that 1 year back Chennai High Court ordered to ban the pouches, milk pouches. That after a lot of reports have come, most of the microplastic that low pH only, it migrates, especially when uses the milk packets when comes. So court told to do that, but industry told no, we don't have the alternative. Glass you can't do that, every day morning you can't do that. So we are also started working, and you are telling cellulose is the one material, but all the biopolymer problem is that strength. We are not able to get the adequate strength and the printability and the barrier property. We need to stop water vapor transmitted from outside to inside, and the carbon dioxide goes inside to outside. So how to increase? One is that fillers we can use MMT clay and other fillers. That's what we try to do that. But now most of the industries, the food industry also is coming forward to develop a lot of products. So hope another 2-3 years time, lot of products may come to the market. Second problem is how to reuse this biopolymer. We are putting so much input into that. That is the what segregation is the another one. We should not allow this polymer to mix with the existing other polymers.
Thank you, sir.
Thank you, sir.
Thank you so much.
To mark our gratitude and sincere appreciation, we would like to present a memento to our speaker, requesting Shri M.C. Dattan, Mentor Science, Government of Kerala, to kindly do the honors. Sir, please. May I now invite Dr. K.B. Ramesh Kumar, Principal Scientist, KCST JNT BGRI, to deliver the vote of thanks.